Math 112, Homework 1.2, Basics of Functions and Graphs, Examples. Example number 1. Determine whether the relation is a function. Give the domain and range of the relation. The most important thing to remember here is that if a set of ordered pairs or a graph or a table or any of the representations of a function that exist show input and output, the input can have exactly one output. So where we see that we have a 2, then a 4, and then a 2, then a 9, this can't be a function because for the input of 2, there is more than one output. So the answer to the first one is no, this is not a function. Now the domain is the set of all input values. So for this relation, it's 2 and 7. And the range is the set of the outputs. So for this function, it's 4 and 9. Number 2. Determine whether the following relation represents a function. If it is a function, state the domain and range. Again, for each input, there can be exactly one output. So you look at your inputs, -9, 8, -8, and 0. That's the first value. Do any of those repeat themselves? And if they do they have the same output value? Well, since none of these input values are repeated, this is going to be a function for sure, so this is a yes. Now, the domain is the set of unique input values, and there are 4 that are different: -9, 8, -8, and 0, which is the first choice listed here. The range is the set of unique second values or output values, and you'll notice that one of those, the 0, is repeated. So we don't need to repeat it here. We just need to write the unique ones. So -7, 0, and -8 is our range. Number 3, determine whether the following equation defines y as a function of x. The only thing for this class that you need to remember for does the equation define y as a function of x is to look at the power of y. Okay? If you have a y squared, the answer is going to be no. And in fact, if you have any even power of y, which we don't really talk that much about, but these would all be no's. The reason for that is that these equations will generate a repeated x with a different y. So the answer would be no if you have a y squared. You might get something like 4 goes to 2 and 4 goes to -2. So you would have a repeated input 4 for different outputs 2 and -2. You'll see this when we talk about circles a little later in this unit. So number 4, determine whether the following equation defines y as a function of x. Here's the situation I was just talking about. We have a y squared here, and it turns out that this is the graph of a circle with a radius of 3. And we've already talked about the vertical line test in class, and what it says is you can't have a function if it crosses a graph more than once. And there we see that that would not be a function. So this is a no, and all you really need to look out for is that second power of y. Now the power of x doesn't matter. You can still have a function for any power of x. It's the y exponent that makes it where y might not be a function of x. Number 5, we don't have any y squared, so that's going to be a yes. Determine whether the following equation defines y as a function of x. Y equals the square root of x plus 27. So that one's a yes. Number 6, determine whether the following function defines y as a function of x. Again, I'm looking at the power of y. Now, there's something that I could do here. It's not required to answer this problem, but just to show you that the technique of factoring out a common factor here, and then I could divide by x plus 5, and then I could see the easy rule for y. Y is 6 divided by x plus 5. So that's definitely going to be a function, because any value of x I put in there is going to give me a unique output. That is a yes. Again, the only thing you really need to worry about is having a y squared. That's going to make number 7 a yes. Absolute value bars around x will not prevent it from being a function, and we have a y to the first power here, and so we're definitely going to have y as a function of x. Now we have a couple where we have to do function notation. When you have f of x, this means the output. The whole thing means the output. We used to just call this y, but now we're using function notation. So in this function notation, f is really the name of the function, and this variable in here is the name of the input. So f of x means you have a function named f for function, okay? And we have variables x in the problem where we will input values. And in this case, they gave us f of x equals x squared plus 4x plus 7. So this happens to be what we call a quadratic function. And they ask us to find f of negative 4 in part A. So here's the thing that's important to remember. If we want to find f of negative 4, that input is negative, and so your calculator understands what you're trying to tell it to do. You need to put it in parentheses. It's perfectly fine to put it in parentheses all of the time, but especially if it's negative or a variable expression. If you leave off these parentheses and you try to use your calculator to find the value, it will evaluate it wrong because you're telling it something that you're not really intending. This is a positive 16. You don't believe me? Try doing this in your calculator. That's going to come up to negative 16. You must have those parentheses. And this is a minus 16 and a plus 7. So the answer to part A is 7. In part B, they ask us to do it for a variable expression. And for the exact same reasoning, I'm going to put it in parentheses so I can remember what it is I'm trying to execute here. So if I'm trying to do f of x plus 2, that means I need to put an x plus 2 in the first x and an x plus 2 in the second x, and I need to surround it with parentheses. The parentheses will remind me that I have other operations I have to do here. For example, this one's the easy one. That's distributive, 4x plus 8 and then plus 7. Now the x plus 2 with the outside square should tell you that you need this base twice, right? That's what an exponent means. It means take the base, the number of times you see here, and multiply it. Well, by having the parentheses around it, it reminds us we have to use the full rule. That is, we multiply the first two, x squared, the outer two, 2x, the inner two, 2x, and the last two, 4. And then if I have like terms, which I certainly have here, 2x and 2x is 4x, I combine those terms together. So here I have x squared plus 4x plus 4, and then it's plus the 4x plus 8 plus 7. Now my math lab is going to expect you to clean this up a little bit, okay, by combining the terms that are alike. So x squared has no other like terms. There are no more x squared terms. but 4x and 4x makes 8x, and 4, 8, and 7 are all numbers, and those add together for 19. So when we evaluate f for x plus 2, we get this expression, x squared plus 8x plus 19. And there's not anything we can do with that. Okay, if we had a number, we could evaluate it, but we don't have a number. So that's our answer, is that expression. Now, something we'll be looking at pretty soon is the symmetry of graphs. And so we're going to look at f of x and f of negative x. And this is going to tell us something about the graph of the function. Again, I'm going to replace every x in parentheses with negative x. And I'm going to see that a negative x times a negative x, that's what that means, two of these guys, is still going to be positive, and it's going to be x squared. But a positive 4 times a negative x is going to be a minus 4x, and then plus 7. So the answer to number 8 is x squared minus 4x plus 7. Number 9. Evaluate the function h of x equals x to the 4th plus 8x squared plus 7. The first thing they ask us to evaluate the function for is 2. H of 2 would be 2 to the 4th plus 8 times 2 to the 2nd plus 7. And because of order of operations, I have to execute these exponents first. So 2 to the 4th is 16. Use your calculator, 2 caret key 4. Plus 8 times 4, that's going to be 32. Add 7 will be 55. And certainly use your calculator as much as you can. I might want you to write this out, but all the rest of this you can skip down just to the answer 55. And in part B, h of negative 1 is going to be negative 1 to the 4th plus 8 times negative 1 to the 2nd plus 7. So again, exponents first. A negative raised to an even power is going to be negative 1 times negative 1 times negative 1 times negative 1 is going to be positive 1 plus 8 times 1 plus 7. That's going to be 1 plus 8 plus 7. That's going to give me 16. H of negative x. So if h of x is x to the 4th plus 8x squared plus 7, h of negative x is negative x to the 4th plus 8 times negative x to the 2nd plus 7. So that gives me x to the 4th. For the same reason, negative 1 to the 4th gave me a positive 1. You've got 4 bases of negative x. Those negatives, an even number of negatives, will be a positive. This is going to be plus 8x squared and then plus 7. And again, notice how these are exactly alike. That's going to tell us about the symmetry of the graph. So that the answer for h of negative x is x to the 4th plus 8x squared plus 7. And now, finally, h of 3a. That means instead of the x, we're going to put a 3a in parentheses. So that's 3a to the 4th plus 8 times 3a squared plus 7. Now, this is not the FOIL rule. The FOIL rule you use when you have a plus or minus, a sum or difference in your parentheses. The rule for this just says, hey, 3 gets raised to the 4th and a gets raised to the 4th. Never ever do that if you have an addition or subtraction. But for a multiplication problem, that's all we have to do. This is going to be 3 to the 2nd, a to the 2nd, plus 7. So 3 to the 4th, use your calculator. That's going to be 81a to the 4th plus 8 times 9a squared plus 7, which is 81a to the 4th plus 72a squared plus 7. So 81a to the 4th plus 72a squared plus 7. Number 10, evaluate the function at the given values of the independent variable and simplify. This time, we have a function named f of x. It is 4x squared minus 1 over x squared. So they're giving you a preview of another kind of function that we will do later, a function that has a fraction in it. It's called a rational function. They ask for f of 2. So that's going to be 4 times 2 squared minus 1 over 2 squared. Now, the most important thing here is that you don't cancel these out, right? The reason for that is this minus 1 has to stay with this, okay? It's like the minus, when you have terms, you can't cancel out part of it, okay? Adding or subtracting are terms. So you have to go ahead and do everything in the numerator. 4 times 4 minus 1, and that's over 4. So that's 16 minus 1 over 4, or 15/4 is my answer. 15 over 4. If this final part will reduce, you certainly can reduce it, because now you just have a single term in the top and the bottom. And in this case, this is a fraction that won't reduce, so we just leave it as 15 over 4. Very similar for when we do negative 2. So we have f of negative 2 is 4 times negative 2 squared minus 1 over negative 2 squared. Again, no canceling. Be careful. Execute the numerator, execute the denominator, and then reduce. So my final answer, again, is 15 over 4. No canceling of these right here. That would be bad. That would not be allowed, and neither would this 4 with this 4. And the reason for that, this minus 1 has to stick with the other term in the numerator. So just do the entire numerator, the entire denominator, and then at that point you can divide it or reduce it if it's necessary. And the last one in this problem, number 10, is to find f. And the last one for problem number 10C is to find f of negative x. And again, I told you that this would tell us something about the shape of the graph later on. So it's important that we're able to evaluate a function at negative x. I need my parentheses around this. What you'll notice is that it turns out to be the same as f of x, okay? And that's going to be important later on. So this one was also 15 over 4, and this one was the original 4x squared minus 1 over x squared. So evaluating a function isn't hard. The hardest part usually has to do with signs, or when there's a variable expression, there's a little extra algebra involved. You just have to take your time. Remember your full rule, your rules for exponents and such. Number 11 asks for the vertical line test. The vertical line test says if I draw a vertical line anywhere on this graph, how many times does it touch it? If it touches it just once, it is a function. Notice I touched it just once. I touched it just once. So yes, y is a function of x as long as it crosses once. Now here, if I draw in number 12 a vertical line, you'll see it crosses it twice. And if I draw it on the edge of that rectangle, it crosses it everywhere. So y is definitely not a function of x for this one. It fails the vertical line test. This one is going to pass the vertical line test. So yes, y is a function of x. And just be sure you read these carefully. Sometimes they put them in different order. Okay? In number 14, they ask us to find the value of f of 6. That means x is 6. Find y. That means the input is 6. What's the output? So I go over to 6. Right here, 6. And I find that y right there, which is -4. So this is a -4. Same thing for number 15. Use the graph to find f of 8. That means x is 8. Find y. So here's 8. I got to go up here, go over. That looks like it's at 7. So reading graphs to find input and output. Here they give us x is -7 in a function named g. Here's our picture of g. If x is -7 right here, what's the y? It's 8. Now you have to be careful on number 17. They ask this in the different order. For what value of x is g of x equal to 5? So basically they're saying y is 5, find x. So it's in the opposite order of these other problems. So if y is 5, I go here on the y, it's 5, and I find a point on the graph, and I get -6. Now, sometimes these have two answers. If this graph had gone this way, it would have had an answer here and here. But in this particular case, we only had one answer. But look out for that. Sometimes when they give you the y value, you may have more than one x. That is definitely possible even with a function. So number 18, use the graph to determine the function's domain, B, the function's range, C, the x-intercepts, if any, D, the y-intercept, if any, E, the missing function value indicated by the question marks below. So the domain is the set of all x's wherever the graph exists. Now, we only have a portion of this graph. The arrow, let me draw just kind of a little quick sketch, something like this. This arrow means this graph is going to keep going. It's going to keep going to the left, and it's going to keep going up. And this graph means it's going to keep going to the right, and it's going to keep going up. So our domain, that is anywhere down here where there would be an existing part of the graph, is going to be -infinity to +infinity. However, the range is not unlimited like this domain because look, it drops, it has a low point where it drops, okay? So this graph, so if I sketch this graph, again, you'll notice there's a low point here. That's the lowest range value, and it's at -1. Now, -1 is included because if they didn't want us to include that, there'd be an open circle right there. We don't include infinity because you can't actually reach infinity. And how high does it go? Well, these arrows indicate it keeps going up, so that's also +infinity. And by the way, you don't have to write the plus. You can just write infinity. Now, let me pause briefly to talk a little bit about interval notation because this notation that they're calling interval notation works like this. Smallest value on the graph, comma, largest value on the graph, parentheses if it's not included, bracket if it's included. So sometimes it looks like an ordered pair. You might have parentheses 3 to 8, but that means the x went from 3 to 8 in this context. X-intercepts, where does it cross x? Right here and right here, so 0 and 4. And they just want us to list those values. As ordered pairs, your x-intercept would have a 0 for the y. So you could write these x-intercepts as ordered pairs, and they would be 0, 0, and 4, 0. Because it's on the x, the 4 goes in the x position. The y-intercept is, let's see, also 0. Look, it crosses y at 0 also. And that would be the ordered pair 0, 0. And that would be the only y-intercept. Now they ask us to find f of negative 2. So that means go over to negative 2 on x and go up here, and it looks like it's 3. And f of 2 looks like it's negative 1. And sometimes it's kind of hard with these little graphs to read, and you have to just be careful to make sure you have the right value. Number 19. Use the graph to find the function's domain, the function's range, its x-intercepts, its y-intercepts, and the indicated value. So the domain here is limited because, look, there are no arrows on the ends of our graph. It goes from here to here. Now, it's a closed circle here. That's going to mean bracket, and an open circle here. That's going to mean parentheses. Included, excluded. On the x, it starts, the x is this horizontal one, so it goes from 0 to 4. And the 0 is included, but the 4 is not. And so that's our interval notation. The range is from bottom to top, smallest to largest. The range goes from negative 9 included all the way up to 7 not included. The x-intercept, where does it cross? It crosses at 3. You could write that as an ordered pair 3, 0, although that is not what MyMathLab is expecting you to do. The y-intercept is at negative 9. That would be the ordered pair 0, negative 9. And the value of y when x is 1, you kind of have to just be really careful here. It looks like it would be negative 8. Because remember, it's not at negative 10, it's at negative 9, and then that's going to be 1 up from negative 9, so it's going to be negative 8. And number 20, use the graph to determine the function's domain, the function's range, the x-intercept, if any, the y-intercept, if any, the function values indicated below. So the domain, look at these arrows. It's going to be negative infinity to positive infinity. The range, though, only drops as low as 4. But then this arrow says we're going to keep going up, so 4 to plus or just to infinity. There are no x-intercepts this time. It never crosses this x-axis. Look, this one stays flat, and this one goes up. And unless you're told that there's something else that happens out there, you will assume that the graph continues the way it looks in the smaller graph. So the y-intercept is 4, right? Crosses the y at 4. F of negative 2 is 5. So you have to be careful, go over here negative 2 and then go up. It's 5. And then f of 4 is 4. And so is f of 1 and f of 2 and f of 3. We call this side constant because no matter what you pick for x, y is always going to be 4. Now, when I post these sample problems, there's always a blank one, and you'll see that the solutions just written out are listed here. So you can always work through these again on the blank one and then check your answers to make sure that you understand it.